and welcome back to Sci-Fi Tech. In this video, I'm going to show you how to make a very simple Attiny85 LED matrix robot with using an Attiny85 microcontroller and a TIP122 Darlington transistor. Let's get started. And these are the items you're going to need to make for this project. The items you're going to need: some Neodymium magnets, a push-button lock switch, a slide switch, a 1N4007 rectifier diode, an Attiny85 microcontroller, a TIP122 Darlington transistor, an 8-pin IC socket holder, a 10K ohm potentiometer with a knob, a 9-volt battery clip, a 9-volt battery, a 3-volt button cell battery, a 3-volt button cell battery holder, a DC gear motor, an 8x8 LED matrix, some Lego wheels which will go onto the DC gear motor, a perf board which is for the Attiny and for the 8x8 LED matrix, and a second perf board which will be for the speed motor controlling circuit, and some screws and these knobs which will go onto the DC gear motor, and you're going to need some cardboard. And this is the schematic that is for the speed motor controlling circuit. And this schematic is for the 8x8 LED matrix and Attiny85 circuit. Now let's go ahead and assemble this project and let's get started. First, solder tin these pads that is on this perf board, and this perf board is for the speed motor controlling circuit. Solder tin it like this, and now take the slide switch and solder it into place. And now take the perf board, turn it around. Next, take the 50K ohm potentiometer and place it into the perf board. And now solder it into place. Next, take the TIP122 Darlington transistor, place it into the perf board. Next, bend over the base lead of the transistor to the center pin of the potentiometer, and then bend over the collector lead over to the side pin of the potentiometer. Solder it into place. Next, take a bridge wire, place it right here over to the base of the transistor. Doing this will make it easier to solder to the center pin of the potentiometer. Solder it into place. And there, base is now soldered to the center pin of the potentiometer. Next, take another bridge wire and connect the collector over to the side pin of the potentiometer. And there, the collector is connected to the side pin of the potentiometer. Cut off the excess. Next, I want to take a 9-volt battery clip, connect the positive wire of the 9-volt battery clip over to the collector of the transistor. The idea is to place it behind, just like this. Clamp it down. Bend over the wire to the collector. Solder it into place and solder bridge the positive over to the collector. Next, take the rectifier diode. Bend the leads over like this. This side's negative, this side's positive, and I want to make sure the negative is placed over here, which will connect to the potentiometer. Take the negative lead of the rectifier diode over to the free lead of the potentiometer, which is the second side pin of the potentiometer, and I'll bend over the positive lead in the opposite direction, solder it into place, and I'll solder bridge the negative to the potentiometer. Cut off the excess. Next, take the negative of the 9-volt battery clip, and I'm going to place that next to the negative of the rectifier diode. Clamp it down, bend over the wire, solder it into place, and solder it to the negative of the rectifier diode. Next, I'm going to take the positive wire from the 9-volt battery clip and connect it to the slide switch. Stretch out the wire so that way I can be able to solder to the slide switch. Remove the insulation. Solder tin it. Solder tin the second wire, and now solder to the slide switch. and then solder the second wire to the slide switch. Next, I'm going to take the DC gear motor and choose one of the wires because polarity doesn't matter. Take one wire and connect it to the positive of the diode, and then one wire over to the emitter of the transistor. Put the wire into place, clamp it down, bend over the lead, solder it into place, and solder bridge it over to the positive. Cut off the excess, and now take the second wire, place it over here underneath, carefully maneuver the wire just right, place it right here, which is just fine, bend over the lead of the emitter, bend the wire over to the emitter, solder it into place, and solder bridge it over to the emitter. And there, this circuit is now complete. Let's go ahead and test it out. Plug in the 9-volt battery. Turn on the switch, and now turn the potentiometer. And there, as you can see, it works. I have the knob turned down low, and you can see the gear motor is moving slowly. And now turn the knob on high, and you can see the gear motor spinning faster. There, as you can see, it works. And it can also turn on and off easily. This circuit is now complete. Put this to the side. And now it's time to work on the second circuit that has the 8x8 LED matrix and the Attiny85 microcontroller. First, start with the second perf board, and then take the 8x8 LED matrix, place it in just like this. Right here is a good spot. Hold it down carefully. Put a little solder on the soldering iron. Push down the lead flush with the perf board, and then touch one of the leads. This will hold it in temporarily, and now, since it's flush with the board, solder in the rest of the pins in place. Remelt the solder and press down on the 8x8 LED matrix to make sure it's flush with the board, and now solder in the rest of the pins in place. Next, take the 8-pin IC socket holder, place it in just like this. Right here is a very good spot. Clamp it down, solder in only one pin, and now simply press down on the IC socket holder. Remelt the solder. Doing this will make it flush with the board. And now solder the rest of the pins in place. Next, take the push button lock switch, place it right here next to pin 8. This will turn the circuit on and off. Bend the leads over in opposite directions, so that way it stays in place. Solder it into place. Next, take the 3-volt button cell battery holder. This side's positive, this side's negative. I'm going to take the positive and place it next to the push button lock switch. Place it in just like this. Solder it into place. And now take a bridge wire and connect the positive terminal of the 3-volt button cell battery over to the push button lock switch. Solder it into place and solder bridge it together. Cut off the excess. And now take the excess and bring it over to the push button lock switch and connect it over to the pin 8. Solder it into place. And there, the push button lock switch is now connected to pin 8. Next, take another bridge wire and connect the ground of the 8x8 LED matrix over to pin 4. Cut off the excess. And there, soldered into place. The pins on the 8x8 LED matrix is a little too long, so simply cut them. And there, that looks a lot better. Next, I'm going to take this wire, connect pin 4 over to the negative terminal of the 3-volt button cell battery holder. And there, this circuit is now grounded. Next, I'm going to take this positive wire, solder it to the VCC of the 8x8 LED matrix, and then solder it over to pin 8 of the IC socket holder. VCC connects to pin 8, just like this. Next, I'm going to take this wire and I want to connect the SDA of the 8x8 LED matrix over to pin 5. This is the SDA right here, and over here is pin 5. Solder to SDA, and now solder over to pin 5. And now take this wire and connect it to SEL, which will connect to pin 7. And there, this part of the circuit is now complete. And there should look just like this. Next, take the Attiny85 microcontroller, place it into the IC socket holder. And now take the 3V button cell battery and place it into the 3V button cell battery holder. And there, the circuit is now complete. Now let's go ahead and push the button to turn it on. And there, as you can see, it works. And as you can see, it works very well, very nice. And the code for this project is down in the link in the description below, or you can click on the annotation above to be able to see how I programmed this Attiny85 to be able to have this type of animation, which I've done in previous videos. And now it's time to assemble everything together. I have right here these knobs and screws and Neodymium magnets, and the first circuit. I simply need to assemble everything together to create this robot. First, I'm going to take the speed motor controlling circuit, figure out the direction of which way the gears are spinning. This right here is the orientation, so this means this is how I need to position the robot. Basically, this right here is the top. Pin doesn't work, so I have to do something else. I have to memorize that this is the top. Take these knobs and connect it to the DC gear motor. Connect it to the shaft of the DC gear motor. Just like this, and the idea is to take the 9V battery and place it right here, and then a circuit on top of the 9V battery. Next, take some dots of hot glue and place it on top of the DC gear motor. And now take the neodymium magnets and glue them into place. Quickly before the glue solidifies. Add some more hot glue to make sure it stays in place better. Accidentally melted that glue, so that magnet flew off. That's okay, I can re-stick it. And now add some super glue to it. This will add some extra strength, making sure it stays in place. And there, the neodymium magnet stays in place. Now go ahead and take the 9V battery, place it on top, which will hold the 9V battery into place. Next, take a piece of cardboard and cut off a piece that is the same size as the circuit. Put a generous amount of hot glue on the bottom of the circuit. And now, glue the piece of cardboard to it. Doing this will insulate the circuit to prevent any short circuits. Next, add some hot glue to the cardboard. Don't use super glue because it absorbs. And then place some dabs of hot glue and then glue in the neodymium magnets. And they're glued into place just like this. Which means now I can take the 9V battery and place it onto the DC gear motor, just like this, and then take the circuit and place it on top. Doing this will hold everything into place. Better if the wires were a little longer, but still, this works very well. Whenever I need to change the battery, take the circuit off, and then take the 9V battery, remove it, and then get a new one, plug it back in. Place it back on top of the DC gear motor, and then take the circuit and place it on top. Doing this will hold everything into place. And there, should look just like this. Next, I'm going to take some Lego wheels. Put a generous amount of hot glue on the Lego wheels. Hold it carefully, and then take the DC gear motor and glue it into place. And there, the back of the robot has some wheels. As you can see, there are some holes in these knobs, and I'm going to take a screw and put it into the holes. I think this position right here is a good size. Looking like this will allow it to walk better. Carefully put it into place. Put some hot glue inside the holes. And now take the screw and screw it into place. Twist it around to make sure there's enough glue contacting the screw. Add some more hot glue to secure it in place better. And there, it should look just like this. Make sure it's nice and straight. Okay, now as you can see, the glue is glued into place. Nice, strong, and solid. Let's go ahead and test it out. Turn the knob a little bit. Uh-oh. Okay, that's a problem. Okay, I'm gonna have to do some adjustments. Okay, so those screws were a little too long, so what I need to do is shorten them. I can't cut them, so I just simply screw them into place, so that way it'll have 2 contacts instead of 1. This will make the robot move a lot better. Now let's go ahead and test it out. Yeah, there we go. It's about the same size. So now I can go ahead, put this in like that. And now, let's give that a try and see what that looks like. Place it right here. Much better. So now I'm going to go ahead and connect the second circuit on top. The idea is to place it like this, which I think looks very good. So what I need to do is take a piece of cardboard, place it on the back of the circuit, and connect it to the other circuit. And then simply wedge the cardboard between the transistor and potentiometer. I have right here the right size cardboard. Wedge it in just like this. And now I need to get the idea of how high the cardboard needs to be. So far this looks good. This height looks good, so now cut the cardboard to size. There we go, it should look just like this. Next, place some hot glue on the back of the circuit. Take this piece of cardboard and glue it into place. Put it into place, make sure it's nice and even. And now add some more hot glue to glue it into place better. And there, it is now glued into place, nice and strong. Something else I've noticed that will make it work better, over here I'm going to take some neodymium magnets and glue them into place. I just need to take a couple stacked up. Put a little bit of super glue right here on the back of the circuit. Take the neodymium magnet, place it there, spray some kicker, secure the glue, and there, it should look just like this. And there, the project is now complete. Let's go ahead and test it out. Attach it right here like this. And it stays in place, just like this. There. And now I have the robot. And now, what's really good about this part is you already know about this part where I can remove it. And I can take this part off, and then change the battery. And then put a new battery in and put it here, and put it here. I have the idea now where I can take this, put it here, and then take it off, and then change the battery here, and put a new one, and then put it here. And then I can attach it here where it attaches to the 9-volt battery. And now I can just simply turn it on like that, and turn on the switch in here like that. Okay, so now what I've done is I've changed the battery to a battery that has better contact, because using a battery that has a bunch of tape on it kind of makes it not contact the magnets very well. So the magnets stick to this a lot better and a lot stronger. And because of that, I had to add some more neodymium magnets right here in order for it to stick onto here. So this top part can stick like this. Now, let's go ahead and test it out. Turn the knob and I can control the speed. Let's make it go slow. And there you have it. Now you know how to make your very own Attiny85 LED matrix robot with using a tip-122 Darlington transistor. Thank you for watching Sci-Di Tech. I hope you learned something new, and don't forget to like, share, and subscribe, and of course click on the bell icon to be notified of future Sci-Di Tech videos. To the next tech, goodbye.